On December 24, 2024, the Parker Solar Probe became the fastest object ever created by humanity, achieving a speed of 430,000 miles, or 692,000 kilometers per hour, when it reached perihelion around the Sun on its last pass. This overtook the record speed set by the Helios satellites in the 1970s. Prior to the Helios satellites, however, the record holder for the fastest man made object is probably not what you'd expect. One would be forgiven for thinking it's another spacecraft, since the ability to use planets as gravitational slingshots to increase speed gives space vehicles an inherent advantage in the look how fast I can haul ass competition. And if you did think that, you would technically be half right? Possibly. That's because the fastest man made object prior to Helios wasn't a vehicle, and whether or not it actually made it to space is debatable. As it turns out, the fastest man made object prior to the 1970s was a metal plate that was welded to the top of a shaft dug into the ground. It was 4 inches or 10.6 centimeters thick, 4 feet or 1.2 meters in diameter, and weighed 1 ton or 900 kilograms. So, how does a 1 ton steel plate that's welded to an underground shaft wind up setting the then record for the fastest man made object? Now, almost everything of significance that happened in the 1950s can be treated like a game of 6 degrees of Kevin Bacon. Just replace Kevin Bacon with the Cold War. And, if it involves the Cold War in the 1950s, the nuclear arms race between the United States and the USSR is probably at least one of those degrees of separation. Early nuclear weapons tests for both of the Cold War's top two pseudo combatants occurred above ground. Most of the bombs were detonated in the air because that would be the intended use case if dropped on an enemy. Many of the tests occurred in the 7 sites in the western United States in the states of Colorado, New Mexico, and Nevada. In 1963, the Limited Test Ban Treaty forbade any detonation of nuclear weapons above ground, in space, or underwater. So all further testing had to be done underground in sealed environments to contain the radiation. Complaints about atmospheric testing were prevalent even before the treaty, though, since people had pretty much figured out by that point that radioactive air and dust wafting through their communities may not be the best for long term health. Even before the treaty, the US government had already begun to build sites to do underground nuclear tests in. And that's where our metal plate comes in. Now, you may have noticed in the video title the question is asked if we, as a species, accidentally launched a manhole cover into space. And that's because, for simplicity's sake, plate is often referred to as a manhole cover. That's because it was similar in shape and served a similar function. It wasn't truly a manhole cover, though, seeing as how it wasn't covering a sewer entrance and manhole covers typically aren't welded in place. Now, I could just end the video here and say, no, we didn't launch a manhole cover into space by accident, because it technically wasn't a manhole cover. Loophole. But the semantics of what the disk is called isn't the point. It's whether or not the plate, or disk, or cover, or whatever you want to call it, actually made it to space. Enter Operation Plumb Bob. Operation Plumb Bob was a series of 29 nuclear test detonations in Nevada in 1957. Amongst these were the first attempts at underground tests. Test Pascal A occurred on July 26, 1957, where a bomb was lowered to the bottom of a 500-foot or 152.4-meter borehole and detonated. The yield from that weapon was significantly greater than expected. I'm no physicist, but I think this might have had something to do with the fact that the force from the blast would have followed the path of least resistance and largely traveled up the borehole, funneling it. There was a concrete cylinder that was lowered into the hole about halfway down that was intended to capture data of the blast using the sensor on top. The thickness of the cylinder was estimated to be between 5 to 7 feet, or 1.5 to 2.1 meters, depending on the source. No matter the actual thickness, though, the concrete and the sensor were never found. They were assumed to have been vaporized by the blast. Seeing as how this borehole didn't have a containment cap on it, the blast escaped to above ground, where, according to test director Robert Campbell, it caused a, quote, big blue glow in the night sky. Test Pascal B was scheduled for August 27, 1957, and someone got the idea that maybe they should cap the borehole for that test. They didn't, I don't know, send a Godzilla atomic breath weapon style jet of nuclear fire into the sky. The decision was made to put the 4-inch by 4-foot, 1-ton steel cap at the top to contain the explosion and any accompanying radiation. The task of doing the calculations for what to expect from the explosion fell to Dr. Robert R. Brownlee. When he ran the numbers, he quickly realized that this welded-on cap was going to be grossly insufficient to contain the shock wave of the blast. On top of that, as part of the experiment, they were going to put a 2-ton or 1.8 metric ton concrete plug with instrumentation just above the bomb to monitor the explosion. What this would wind up doing was effectively turning the shaft into a gigantic nuclear powered rifle with a 2-ton concrete bullet. So, realizing the cap on the shaft had no hope of actually containing the explosion, and that they were possibly about to fire a 2-ton concrete bullet into the sky, what did they decide to do? Did they create additional pathways to the blast site so the force could spread out? Did they reinforce the steel cap so that it might have a chance of containing the localized radioactive hell that was about to befall it? Did they think better of the whole idea because possibly firing an atomic bullet the same weight as an American bison wasn't the best plan? They did exactly none of those things. What they did do was put a high speed camera on the cap to see if they could catch how fast it flew off. I think this may be one of the best examples of the phrase close enough for government work that I can think of. I guess if you make the failure part of the experiment, it's no longer a failure. It's an experimental data point. It is a bit disconcerting how much of early nuclear testing boils down to what amounts to Wile E. Coyote contraption level engineering. So at 3:35 p.m. on August 27, 1957, the bomb for the Pascal B test was detonated. Just like Pascal A, the yield was higher than anticipated, and the concrete plug likely vaporized, at least solving the atomic bullet problem. As expected, the cap flew off the end of the shaft. Dr. Brownlee described it as going like a bat. I'm assuming maybe he was a religious man and that's why he left the out of hell part off, but the statement gets the point across nonetheless. The high speed camera they'd set up to monitor the cap was set to capture 1 frame per millisecond, or 1,000 images per second. The time between the cap detaching from the top of the borehole to the time it's out of the sight of the camera was 1 millisecond. It only appeared in one frame. The approximate speed the plate was moving was estimated to be about 41.75 miles per second, or 67.2 kilometers per second. That puts a speed at roughly 150,000 miles per hour, or 242,000 kilometers per hour, which is about 6 times the speed needed to achieve the escape velocity from the Earth. Now, other estimates did provide lower numbers, some as low as 120,000 miles per hour, but still significantly higher than Earth's escape velocity. So that settles it, right? We shot a steel plate into space. At the speed that thing was going, there's no way it stayed on Earth. Well, like any physics problem with multiple variables, it's not quite that simple. There are a few things at play here that could have affected what happened to the cap. First, the force coming up from below on the plate would have been caused by the rush of superheated gases resulting from the detonation. Again, both force and mass have a tendency to follow the path of least resistance. The steel plate itself probably wasn't perfectly uniform. Any variations in thickness or composition, no matter how small, could have affected how the force was distributed across the welding. And as for the welding itself, it likely wasn't perfectly uniform all the way around the plate. Any derivation in the weld quality would have provided a preferred path for the superheated gases. Coupled with the variations in the plate, this could have created an uneven separation from the top of the shaft. That becomes potentially important because an uneven distribution of force can do two things: deform the plate, or impart rotation onto it. Deforming it could have an effect on its aerodynamics as it hurtled through the atmosphere, and having the plate rotate could have altered its trajectory. The further away from a directly vertical path the path of the plate was, the longer it would have stayed in Earth's atmosphere, and the longer that air resistance and gravity would have to slow the plate down. Although, given the pressure from the blast wave reached the plate in 31 milliseconds, and it separated the plate from its welding and shot it out of frame of the camera in less than 1 millisecond, it's possible neither of the points that I just made is even significant. If the pressure was so high that the welding failed practically instantaneously at all points, and considering the sheer amount of force hitting the plate, that's a distinct possibility. It's possible the plate just shot up, effectively perfectly vertical, with negligible deformation and rotation. So little information was able to be gathered from one image from a 1950s high speed camera that deformation and rotation couldn't be determined. Even the velocity calculation was an estimate because that couldn't be mathematically determined from the one data point either. So then, what did become of that plate? I think there are three most likely scenarios for it, with varying degrees of likelihood. First, with the ridiculous speed it was traveling at, and the extreme heat from the air resistance that would have come along with that speed, The plate could have been destroyed or just disintegrated prior to reaching space. Second, it could have actually made it to space. At the speed it was estimated to be traveling, it would have only taken 1.8 seconds to reach the Kármán line, which is considered the boundary between Earth and space. From there, one of two things could have happened. It would have been slowed enough due to gravity and air resistance to be captured by the Earth and fall into some kind of orbit, or it got away clean and zoomed its way through our solar system. Let's take a look at the disintegration scenario first. Many scientists are skeptical the plate actually made it to space. One common criticism of the speed estimate is that it assumes a vacuum and or negates air resistance. Obviously, this isn't the case on Earth, or my oxygen-powered organic meat body wouldn't be around to type up the script, and you wouldn't be around watching this video. If the plane was going at a lower speed than estimated, it would affect how much air resistance was being applied to it. However, it would actually decrease the force of the air resistance and subsequently the temperature, making it less likely to disintegrate. It would, however, also give gravity more time to slow the plate's progress down. A disc shaped piece of steel is, even in the best case scenario of being perfectly vertical, not very aerodynamic, so the reduction of speed in the air would be potentially significant. If gravity and air resistance managed to slow the plate down enough to get it underneath the escape velocity before it actually escaped, it's possible it would have come crashing back down to the ground. This would leave a tiny crater in the desert where it landed, but by now that divot would likely be smoothed over by nature. No such impact site has ever been found, nor any evidence of the cap landing anywhere on Earth. The second argument is that the friction from the air initially would have generated enough heat to effectively vaporize the plate immediately. If this were the case, it would neither have reached space nor returned to the ground, and there would be no evidence to find. Of course, these ideas are both disputed, and it's not even clear which side of the argument Dr. Brownlee, who made the original speed estimate, falls on. He wrote an article in June of 2002 entitled Learning to Contain Underground Nuclear Explosions, in which he stated, quote, "As usual, the facts can never catch up with the legend, so I am occasionally credited with launching a, quote, manhole cover into space, and I am also vilified for being so stupid as to not understand masses and aerodynamics, etc., and border on being a criminal for making such a claim." But in an interview with the publication Business Insider in 2016, Brownlee stated, quote, "After I was in the business and did my own missile launches, I realized that the piece of iron didn't have enough time to burn all the way up." If the latter statement by Brownlee is assumed to be correct, that leaves the option that the plate, or at least some part of it, actually made it to space. Then the question becomes, did it get captured by the Earth, or is it just on a merry little adventure to whatever direction it was pointed at? If we theorize that the air and gravity slowed it enough that it could have been captured, then the trajectory becomes a pertinent part of the conversation. If we assume the plate went in an effectively perfectly vertical path and got captured, then it would fall back on the same path. This means that it would fall vertically back into the atmosphere. On the way up, the friction and force of air resistance would be diminishing with distance. When it fell back, air resistance and friction would be increasing along with temperature. There's no way a metal plate could survive re-entry under those circumstances. Vehicles that travel in space, which are designed to be heat and force resistant enough to re-enter the Earth's atmosphere, cannot survive an unimpeded vertical re-entry. That's why the re-entry paths use the orbits to enter the atmosphere at an angle to control force and temperature. The plate was made of steel, and subsequently only had the heat and force resistance of steel. If there were an angular component to the plate's escape, it could possibly have entered an orbit rather than just plummeted back toward the ground only to disintegrate. It would have to be a fairly significant angle, though, and as I stated earlier, this would give gravity and air more time to slow it to sub-escape speeds. And even if this thing made it into orbit, the odds of it being a stable orbit would be low. You need a practically perfect set of calculations to get anything man-made to stay in a stable orbit. And keep in mind, this plate got yeeted into space by a nuclear bomb. Getting this thing airborne was not a precision operation. Most likely, if it did get captured in an orbit, that orbit has since decayed, it's re entered the atmosphere, and burned up by now. If, by some fluke of miracle mathematics, it actually did find a stable orbit, the odds of finding a 4-foot diameter plate, or part of one, in orbit around the planet with all the other space junk up there are practically negligible. Finding it would be at best dumb luck, And that's only if we had the technology to reliably capture and analyze space junk, which we don't. That leaves one more scenario, that the plate made it to space and was still hauling ass fast enough to avoid getting captured. That basically means it should just be zipping through space, right? Well, maybe. Recall that I said the explosion occurred at 3:35 p.m. in Nevada, meaning the plate would have been launched off the sun-facing side of the Earth. Even though the sun is absurdly large, given the distance, if the plate wasn't fired directly at the sun, there's still plenty of room to miss it. I think it's unlikely the plate was fired directly into our parent star. However, the sun is still the dominant force of gravity in our solar system, so it would have likely had some effect, even if minimal, on the plate. The escape velocity of the sun is over 55 times that of Earth, and even the top estimate of the plate's speed was nowhere near that high. Of course, the further from the sun the plate's path actually took it, the lower speed the plate would need to have in order to skip past it. If the plate got close enough to have a significant interaction with the sun's gravity, though, one of two things would happen. It would either get slingshotted in a different direction, or it would get captured and eventually vaporized. If it was far enough away from the sun not to see a significant effect, and also didn't happen to stray too close to any other celestial object, it could just be flying away from our home planet forever. Assuming it remained intact and got to space quick enough not to be significantly slowed, it would have had over 540,000 hours of flight time by now. At the speed of around 150,000 miles per hour, that puts a plate over 89 billion miles away. The heliopause, which is effectively considered the boundary between the solar system and interstellar space, is 11 billion miles away. If the plate shot straight out, survived into space, didn't hit anything, and kept going, it is by far the furthest away man made object in space, surpassing Voyager 1 by several orders of magnitude. That is, of course, only if that one specific scenario is what played out. So, to answer the question in the title of the video, did we, as a species, accidentally launch a manhole cover into space? The answer is maybe. We have so little data on the actual speed, deformation, and rotation of the plate that it's hard to tell. It's most likely either the furthest away man made object by a significant margin, or it's been totally destroyed by now. Either way, for a few brief milliseconds, it was unquestionably the fastest moving man made object ever to exist on Earth. And it still holds that record because all future faster vehicles are in space. And that wraps up the video. If you like the video, or want to credibly dispute any of my physics based assumptions, because I have an entry level collegiate understanding of physics, please feel free to comment on the video. Also, feel free to like and subscribe. And don't forget to ring the notification bell for more weekly content. As always, thanks for watching.